So in this video, we'll look at the chain rule for differentiations. And chain rule is so useful whenever you can interpret a function as a composite functions. And for those of you who are not very familiar with the meaning of composite function, and just to let you know, what I mean by f of g of x is not the same as product of f times g. They are not the same. This one is product. And by a previous video we look at, for a product of two functions, we can actually use the product rule to find the derivative. But currently, I'm actually talking about the composite functions. In case you don't fully understand the meaning of composite functions, we can quickly do an example. So for example, if I pick f of x to be x squared plus 1 and g of x to be x plus 7, and by composite function of f of g of x, we have to look at the inside first. The inside is actually x plus 7 now. This is the g of x. And now, what is the function of f of x plus 7? You have to replace, you see, the x by x plus 7, right? You have to replace x by x plus 7. So it's going to be the same as x plus 7, the whole thing squared, plus 1. So you see, what I did is, you have to replace the x term by the x plus 7 term. So, and if you understand what I mean by f of g of x, you would notice that most likely it is not the same as g of f of x. Because for g of f of x, what you need to do is you have to look at the inside first, which is f of x now. The inside is, by definition of f, is the same as x squared plus 1. So you see, when you have g of x squared plus 1, you have to turn everything into something like x squared plus 1. So I just write it down now. So it means it's the same as x squared plus 1, the whole thing, plus 7. And that's the answer. And as you can see, of course they are not the same, right? So you can expand the brackets on the top, you'll see that they are not the same thing. So that's the meaning of composite functions. In this video, we'll try to find the derivative of a complicated functions if we can view it as a composite functions. So let me explain the chain rule a little bit here. Let's say you have rather complicated functions, which can be viewed as a composite function f of g of x. To find the derivative in this case, by chain rule, it actually is the same as, maybe let v be g of x. Then let's say g prime, of course, is the same as v prime. So please look at this. And why am I doing that? So in that case, we can view the y to be a function of v, right? We can think of it as a function of v. And I have to be very careful about the notation here by dy dv. This one, this notation, if you have not seen it before, it means the derivative of y with respect to v. That's what I mean by this notation, dy dv. And of course, it's the same as f prime of v. And now chain rule basically says that, the derivative y prime, you see, I'm talking about this. And I have to be very careful about the notation. The y prime is the derivative with respect to the original function, the variable x. And by chain rule, the y prime is really the same as the product of two things. So I bring the two terms together. So it's the same as f prime of v times g prime of x. And usually, mathematically speaking, it would be much cleaner if we express the whole answer in terms of x. So I can change v by using the definition v equals g of x to this term inside f prime. So that's basically the chain rule here. So I understand in terms of notation is fairly complicated. I understand it, but we'll do some examples later on. Then you will understand why it is so useful to use the chain rule in so many different cases. And I can look at another notation. So the chain rule can also be written as dy dx. And this one is the derivative with respect to x, derivative. And equals dy dv, which is this one, which is the f prime of v we look at, times. You see this term is basically the same as dv dx, right? Because it's the derivative of the function v in terms of x. If you view the chain rule by using this notation, maybe it's actually easier for you to memorize the chain rule because, well, if you think of them as different variables, it really kind of looks like the dv term here can be cancelled, and this formula obviously looks true, but that's really a good way that you can memorize the chain rule like this. But the fact is that to understand the chain rule well, you have to do more exercises. So the remaining time of this video, we'll look at more exercises. So let's look at the current problem. It is 7x squared plus 1, the whole thing power 5. And let's think about how to find the derivative f prime of x. And to do it, let me apply the chain rule we mentioned before. I can let v be a function of x inside the bracket, which is 7x squared plus 1. If you let it this way, v prime is going to be 14x as the derivative. And in that case, you see the function f of x, if you think of it as y, is going to be y equals v to the power 5, right? Because I'm letting v be this. And dy which is the derivative with respect to variable v, is going to be 5 times v to the power 4. I'm using a simple power rule here. Now by chain rule, we have to bring it in as a product of two terms for the derivative f prime of x. So let's do it together. I write it like this: 5 times v to the power 4 times 14x. And let's simplify slightly. 5 times 14 is the same as 70 times v to the power 4 times x. And it would be much nicer to replace v back to x. So it means the answer is actually 7x times open bracket 7x squared plus 1 close bracket to the power 4. So that's the answer to this problem. Let's look at the current example of the function f of x equals cosine of 7x plus 1. And please try to find the derivative of f based on the use of chain rule, because please think about that. Without using chain rule, we don't have any rules for us to find this derivative. Of course, in your mind, you may notice that derivative of cosine x is a standard differentiation formula, which is minus sine x. So it gives you a hint to see that maybe you can use chain rule to simplify the problem a little bit. If we let v be 7x plus 1. Then in that case, if you think of f as y would be the same as cosine v. And of course, v prime is the same as 7. And y prime, I would like to emphasize, is the derivative with respect to v. It's minus sine v. And by the chain rule, you have to bring in the two functions together as the derivative of f prime. So now f prime is the same as minus sine v, the whole thing times 7. So it means that f prime of x is the same as minus 7 times sine v. And as a last step, you can raise v by 7x plus 1. And that's the answer to this problem. Please look at the current problem. The function f of x is the same as sine x to the power 4. And to be honest, all of these problems can be done by chain rule. And based on experience, you have to let a good v to simplify the whole problem. And that's really the trick why chain rule is so useful. And I think in this case, if we let v be the item inside the bracket, things actually look much easier. For example, if I let v be sine x, we know that v prime is cosine x. And let's say the original function, we call it y. Y now is the same as v to the power 4. And of course, y prime with respect to variable v is the same as, by power rule, is the same as 4 times v to the power 3. And it means that the derivative of the whole function, f prime of x, is actually the product of the two things here. So it's actually the same as 4v cubed times cosine x, and it means 4. We can bring back the v as a function of x, which is sine x, like this. And that's the answer to this problem. Let's look at the current problem. F is equal to e to the power x squared plus 1. And the closest one we have learned is that if we look at the standard function, exponential function e to the power x, if we differentiate it, it is unchanged. That's the closest we have learned before as a differentiation rule. And I think now there's not much you can do except using chain rule. We can let v be x squared plus 1. Then in that case, y is the same as e to the power v, and v prime of course is 2x, and y prime with respect to v as a derivative is the same as the original function e to the power v because of this. So it means f prime of x as a derivative is the product of two things, and which is 2x times e to the power x squared plus 1, because I bring back the meaning of v as a function of x. And next, so please look at the current problem. It looks like we can use a chain rule to simplify the problem slightly, because I can let v be the square root of x squared plus 1, right? And now y is just the same as the function of v, which is a sine of v. And y prime is clear, which is cosine v. However, v prime is not that easy. So why? Because please think about it. V is now, if you view the square root as power half, now v is the same as x squared plus 1, the whole thing to the power 1 over 2. And please think about it this way. This v itself is somehow fairly complicated if you try to find the derivative of x. So I think there's a chain rule here. The chain rule is that you can actually let w be x squared plus 1, then w prime is 2x. Now v, you see, v can be expressed as v equals w to the power half, right? And v prime as a derivative of with respect to w. V prime is the same as half times w to the power minus half by a power rule. So please focus on the purple color. It means v as a derivative of x. I'm talking about v as a function of x. The derivative is going to be the product of these two terms. And we can write it as x times w to the power minus half equals x times open bracket x squared plus 1 close bracket to the power minus half. And this function is actually the derivative of v with respect to variable x. And now let's go back to the beginning. You see, f prime is what? F prime of x should be the derivative of this times derivative of this, which we have done in the bottom line. This one is x times open bracket x squared plus 1 close bracket to the power minus half. And I bring two things together, cosine v times x times open bracket x squared plus 1 close bracket to the power negative half. So that's the answer to the problem. Of course, we should replace v back to the original function. You see on the right hand side, v is actually the same as square root of x squared plus 1. So we should replace it back times x squared plus 1 to the power minus half. And please think about this problem. It's fairly complicated in the sense that you get the f prime out by using chain rule 2 times, because when you take the derivative of v, this one itself is a chain rule. So this problem can be viewed as chain rule of chain rule to get the final answer.